this video, we will present the gray codes. Gray encoding produces the best possible binary assignment in a digital communication system. In the digital modulator, the sequence of bits that contains the information that we want to transmit is converted in a sequence of symbols. Then these symbols have a vector representation. In general, a symbol can be understood as a block of m bits. And in the constellation, every possible combination of m bits must be assigned to one of the symbols of the constellation. And because of this, the number of symbols of the constellation is 2 to the power the number of bits per symbol. The binary assignment, the association of every possible combination of m bits to the different symbols of the constellation, has an objective. The objective is to minimize the bit error rate, to minimize the probability of error at bit level. And the optimal binary assignment technique is gray encoding. Now we are going to see the characteristics of the gray codes. In a gray code, the m bits that are assigned at symbols which are at minimum distance differ only in a single bit. For instance, if this symbol here in this constellation is assigned 0, 0, the two symbols that in this constellation are at minimum distance, A2 and A0, will have a binary assignment that differ in a single bit. For instance, in A0 only the second bit is different, in A2 only the first bit is different with respect to 0, 0. The binary assignment for A1. In gray codes, therefore, symbols at minimum distance will have binary assignments with only a different bit. Why? Because when we have a relatively high signal-to-noise ratio, most of the errors that happen at symbol level are with symbols at minimum distance. If we transmit a symbol, in most of the cases, the mistake will be with a symbol at minimum distance. In this case, with a gray encoding, only an erroneous bit is out of the m bits that we have in this symbol, and the bit error rate is approximately equal to the probability of error at symbol level divided by the number of bits per symbol, because usually in the most common errors we will have a single erroneous bit out of the m bits that are assigned to the transmitted symbol. This idea is relatively intuitive, but we can see it also mathematically. The bit error rate can be computed by averaging the conditional bit error rates given a symbol. And the conditional probability of error at bit level for a given symbol is obtained by the addition of the products between the probability of transmitting this symbol deciding any other symbol in the constellation times the number of errors in bits that happen in this mistake divided by the total number of bits. To minimize the conditional bit error rate, the higher the probability of having a mistake, the higher the probability of deciding AJ when AI is transmitted, the lower that this term must be to compensate the bit error rate. And these probabilities of error are higher for symbols at minimum distance. Because of this, the gray code minimizes the bit error rate for a given constellation. This is the optimal binary assignment technique. Here we have another example of gray encoding, in this case for a QAM constellation. We can see that the bits assigned to a given symbol, for instance to this one, differ in a single bit with the bits assigned to the symbols that are at minimum distance of this one. The independence in the two components of the QAM constellations make very easy to obtain a binary assignment satisfying the gray coding technique, because we can encode with a gray code independently the two components, and then maybe we can assign the first pair of bits to the first direction of the input space, and then the second pair of bits to the second one. In this way, it is very simple to obtain a gray encoding for a QAM constellation. Here we have another example of gray encoding for a PSK constellation. If we have a symbol with a binary assignment, the two symbols that are at minimum distance will have binary assignments with only a single bit different with respect, in this case, to 0, 0, 0. This is gray encoding. This is the optimal technique for binary assignment.